All right, guys, so we're going to start off with section 3.5, equations of lines, and go through all of our equations of lines. We've talked about all three of them. We've talked about standard form, which is your ax plus by equals c. We've talked about your slope-intercept form, which is y equals mx plus b. And we've also talked about point-slope form, which is y minus y1 equals m parentheses x minus x1. So we're going to dive in a little deeper with those. So we're going to talk about using the slope-intercept form to graph an equation. What we're going to discuss here is that when we have slope-intercept form of a line, we have our slope and we have our y-intercept. Okay, we're going to utilize our slope and our y-intercept in a little bit of a different way. So we're not going to actually calculate. We're going to use the information we have to plot points. So 0, 4, B is going to be our starting point. So we're going to start at B. So we start by graphing 0B. And then slope. Slope is like our direction. It's going to tell us where we're going. Okay, so let's apply that here. So for example, we have this point, this equation, y equals 3/5 x minus 2. So when I graph this, I'm going to start at 0, -2. Okay, my slope is 3/5 and my y-intercept is -2. So when I'm graphing this, I'm going to graph 0, -2, and then my rise over run. So my 3/5 tells me what direction I'm going. So because 3 is positive, I'm going to go up 3 units, and I'm going to go right 5 units. So here I go. I started here at -2. Then I rise 3 units, and then I ring in 5 units. And there's my second point. As long as you have those 2 points, you can graph your line. So I graph my line. And you're done. Okay? When you're doing this in your homework, it's going to be a little trickier. Make sure you zoom in so that you can see the points and count as you're rising. You should only double tap on a point on your first point and on your last point. As you're counting, try not to tap the screen. Next, we're going to go over using slope-intercept form to write an equation. Okay, the main thing is understand that you're giving your slope and you're giving your intercept. Okay, that's what you're given. So you're going to use that information to write your equation. So for example, here we have our slope-intercept is 0, -2. So 0, -2 is our slope-intercept, is our y-intercept. I'm sorry, and our slope is 3/5. So we're going to label them as M and B. Okay. So we have our M, we have our B, we plug them in, and guess what? You're done. You just wrote your equation. Okay. Next, we're going to go over writing an equation given slope and a point. So this is where we're talking about using point slope. So our point slope form is not on our green card, but you can go ahead and add it to your green sheet. If you want to add that to your green sheet, you can. So we have y minus y1 equals m times x minus x1. And we're going to use it, especially when we're given a point and a slope. So for example here, this is -11. So let me help myself there. Erasing doesn't be my friend. So we're going to make that -11. It didn't carry over with us. So it's a -11, -12. So with that, our goal is we want to write it in slope-intercept form. So we have slope-intercept, so we want to write it in slope-intercept form, which is y equals mx plus b, and we want to put it in standard form, which is ax plus by equals c. And in standard form, remember, we don't have any decimals or fractions. So we're going to substitute the slope and point into the point slope form. Okay, so the reason why I know this is where things go, if you look right here, this would be my x1, sorry, because it's my given x. So this would be my x1, which is why it says -11. This would be my y1, which is why this says -12. Okay, so I plug those in. Also my slope, notice that my slope is plugged in. My slope is given as -2, so where m would be, I plugged in -2. Okay, so now I clean it up, I simplify. So by simplify, we want to get rid of our parentheses. So notice I go ahead and distribute. After I use the distributive properties, now I'm going to get y by itself. So in order to get y by itself, notice this +12, I have to move it to the other side. So when I move it across the equal sign, I have to use subtraction because the opposite of adding 12 would be to subtract 12. So on this side, I subtracted 12, and that left me with -34. Okay, so that would be part one. So part one would be to get it in slope-intercept form, which it is. Part two is to get it into standard form. And so at part two, in order to get into standard form, I'm going to move my x, because standard form just means we want x and y variables and their coefficients on the same side. So I'm going to move it. So if it's a -2x, to move it, I had to make it a +2x. And right here, they just become neighbors because they're neighbors because they're not like terms. All right. So writing an equation given 2 points. So given 2 points means that I am not necessarily given my slope and my y-intercept. So there are things that are missing in order for me to use either slope-intercept form or to use point slope form. If you listen, the key word is slope. So we're going to go through how to work this. So the main thing is that you're going to need to find your slope, okay? So the first thing is to find your slope. So right here, you notice how I'm given this point and this point. -4, 0, and 6, -1. From there, I'm going to need to label them as x1, y1, and so on and so forth. So this guy is going to be my, trying to write it very carefully, x1, y1, x2, y2. I personally like to label them beforehand because it makes it easier to just simply plug in. That's a 2, just trust me. Okay. All right, so now I can plug in my values. So where y2 is, so here's my y2. So I'm going to plug in what I have for y2, which is -1. Then I'm going to plug in my y1, and my y1 is 0. My highlight is falling behind. Then I'm going to plug in my x2, and my x2 is 6, so I plug in 6. Then I plug in my x1. x1 is -4, so I plug in -4. Okay? Once I plug in, then I just go through a series of reducing. So I have -1 minus 0 is -1. I have 6. At first, I have to distribute my negative here. So when I distribute my negative, a negative times a negative makes a positive. So this really is 6 plus 4. And that equals 10. So now I have my slope. And my slope is -1/10. So with my slope, I now can use point slope form, okay? I typically just stick to what my x1 and my y1 were so that it falls directly into the formula. So my x1 was -4 and my y1 was 0. And now I can just plug them straight into the point slope form and go from there. So once I do that, I can start simplifying. Okay. Now notice how all of a sudden my fraction has disappeared. Okay. Don't freak out. So we want to clear our fraction out by multiplying what's in the denominator to both sides. So right now what's in my denominator is a 10. So I'm going to, before I distribute or anything, I'm going to multiply that 10 to both sides. I like to write it at the top so that I can see that, oh, this is 1/10 times 10. And this is over here, it would be y times 10. There's no point in me doing 0 times 10 because it goes away. So then I'm going to clean it up. So y times 10 is 10y. Negative 1/10 times 10 is just negative 1 because the whole purpose was to cancel out the 10. And now I have a non-fraction problem. And I go through the same steps as before. I'm going to distribute my negative 1, distribute my negative 1, and I get 10y minus x minus 4. And then I am going to add x to both sides in order to get it into standard form. And now it's in standard form, and now I'm done. Next, we have finding equations of a vertical and horizontal lines, my favorite topic. Okay, vertical line. So on your green sheet, it will say that vertical, I'm just going to write V, means that it is x equals a number, and it will say horizontal, so just H, is y equals a number. It says it on your green sheet already. So if it's asking me for a vertical line, this right here is my hint. Vertical line means I want to know what is my x equal to. Well, my x is equal to negative 7. So therefore, I would write it as x equals negative 7 would be my answer. And that would be that. Okay? Now it says find an equation in the line parallel to the line y equals negative 3. Well, we're going to talk about this in reverse. So if I have y equals a number, that means that it has to be a horizontal line, right? So if I have y equals negative 3, that means that I have a horizontal line. What's parallel to a horizontal line? Another horizontal line. So in this case, you're looking for a horizontal line. And horizontal means y equals. So what is our y equal in this problem? Well, our y equals 4. So this would be 4. Okay? So again, what I just said is y equals negative 3 is a horizontal line. Any line parallel to it is also horizontal. The equation with horizontal line can be written in the form of y equals c, c being a number. An equation for the horizontal line passing through 10, 4 would be y equals 4. Okay, so now we're going to go into using the point slope form to solve problems. So, yay, word problems. All right, so word problems. So our first word problem here we have here is in 1997, Window World Incorporated had 50 employees. In 2012, the company had 85 employees. So we're going to let X represent the number of years after 1997 and let Y represent the number of employees. So with that being said, if we assume that the relationship between years and numbers is linear, we're going to write an equation describing this relationship. So we're going to make an assumption that it's linear, that it's constantly changing at the same rate each year. And we're going to make a prediction that the number of employees of what the number of employees will be in 2007, or was in 2007. Sorry. So we're going to start off with the fact that if we let x equal 0, I'm going to make my table. So we have a table of x and y, and x equals 0 is going to be 1997, and in 1997 there were 50 employees, and then 15 years later in 2012, so this would be 15 years later in 2012, there were 85 employees. Sorry, that's just not working out very well. But what you can see now is that with my table and my points, I have 2 points. Because I have 2 points, that means I can find my slope and then do point slope form, right? So I would label my x1 and my y1. So I have x1, y1, x2, and y2, and then I'm going to plug them in. So I have 85 minus 50 over 15 minus 0. Plug in, simplify. So 35 over 15 is going to reduce to 7 over 3. So 7 over 3 is now my slope. Okay? Once I have my slope, I can choose either point, but we're going to choose 0, 50 because it has a 0 in it. So if we get a choice of a coordinate with a 0, we run with it. And we're going to plug them into y1 to y minus y1 equals n times minus x1. So I'm going to plug everything in. So I substituted the values. And now that I've substituted the values in, I'm going to clean it up. So I'm going to distribute my 7/3. And notice how 0 stayed 0 because 7/3 times 0 is 0. And then I'm going to get my y by itself because we were looking for the linear equation. So in order to get y by myself, I added 50 to both sides, and I ended up with my linear equation. So that would be part A, is to get your linear equation. Okay, so we're going to continue to part B. Now that I have my equation, can I solve for how many possible employees that I have in 2007? Yes, but I need to ask myself, how far is 1997 and 2007? 10 years. Okay, so we let x equal 10. Plug 10 in. So there's approximately 73 employees in 2007. Okay, remember when you're multiplying this, make sure you're 7 over 3 times 10 over 1. And that's going to give you 70 over 3. And if you put 70 over 3 in the calculator, that's going to give you about 20. Just had a break for it. 23. So it's about 23 people. We don't pay attention to the decimal because you can't have a portion of a person. You either have a whole or none at all. So this would be 23, and 23 plus 50 is what makes it approximately 73. All right? Awesome. Our next video, we will talk about section 3.6.